What a pleasant day, everyone. We're here to promote our system, named Stepper Motor combined with LED display. Here are the table of contents. First, description. Second, scope and limitations. Third, problem encountered and solutions. And lastly, job distribution. Now let's proceed to description. Stepper motors are DC motors that move in discrete steps. They have multiple coils that are organized in a groups called phases. By energizing each phase in sequence, the motor will rotate one step at a time. With a computer-controlled stepping, you can achieve very precise positioning and speed control. For this reason, stepper motors are the motor of choice for many precision motion control applications. Stepper motors come in many different sizes, styles, and electrical characteristics. While LED display, light-emitting diode display, is a screen display technology that uses a panel of LEDs as the light source.
After the description, let us now discuss the scope and limitations of our program, stepper motor combined with LED lights. Scope and limitations. Stepper motor takes a much larger ampere than other types of motor. This makes the stepper motor less efficient, and the vibration in the motor is also caused by the same issue. As the engine speed increments, the torque of the stepper engine begins to diminish. Hence, in the event that you are searching for an engine that provides tall torque at tall speeds, at that point, choosing this engine may not be the proper choice for you. In fact, LED lighting has only a few intrinsic disadvantages. The foremost well-known shortcoming of driven lighting is that LEDs create a byproduct heat. LEDs are called cell heating gadgets since they create warmth inside the gadget package rather than emanating warmth within the frame of infrared vitality. Around half of the electrical vitality nourished to undriven is changed over into warmth, which must be conducted and convected through a physical wormhole.
And now let's proceed to the problem encountered and solutions. Technical problems we encountered is the first is syntax and logical error. And solutions we made is debugging the system. Of course, we're the programmers and that's the common problem we encounter, so we need to debug the system. And the second is lack of instruction inside the program when emulated. The solution we made is improve the interface with user-friendly system. In the previous system, our system is lack of interaction to the user, so we need to find other ways if you want to provide an effective and efficient program to the users, and those need to complain. And the third problem we encountered is latency of internet connections. The solution we made is checking the internet speed, bandwidth, and restarting the router. Where we are doing the system, latency of internet connection can be avoided for the reason not everyone doesn't have a stable internet connections, especially we are located at one of the slow internet countries in this world. And the fourth problem we encounter is lack of equipment. And solution we made is finding ways to cope up despite the lacking of equipment. Not all of us have equipment, so sometimes we conduct personal grouping since we're located near to each other. So we are always trying our best to finish the tasks that have been assigned to us. And the last is complexity of our first proposed system. The solution we made is came up with a new system due to the complexity of the previous system. The first system that we proposed is traffic lights with LED display. We thought that we can do that, but we didn't. So we took the plan B, and that's the stepper motor with LED display. Do you need have a choice of every situation? If a plan B didn't work, oh geez man, we have a 26 letters in the alphabet, so you need to look in the other angles. Just keep it up. And now we proceed to Mr. Sevilla again to discuss the job distribution.
Thank you for that wonderful transition to my part, Mr. Laksamana. And now we will discuss the last part of our reporting, which is the job distribution. On the description, It is worked by Cruz, Kurt Dominic S., and Laksamana John Paul G. On part of the scope and limitations, it is worked by me, Sevilla Fritz Gerald R. On part of developing the system, it is worked on by Cruz, Kurt Dominic S., and Laksamana John Paul G. And on the last part of the job description, which is the documentation, it is also worked by me, Sevilla Fritz Gerald R. Thank you for listening.
Before we proceed to the actual demonstration, I would like to share the main objective of our program, and it's to serve as a continuity test to LED lights. In virtual devices like this, we know that it is easy to determine if it will work due to the given logic and accuracy of our created programs. But it is a different in the actual material. Of course, not all stepper motors can conduct voltage that can help the LED lights up. That's why we combine the LED lights and the stepper motor so that it can determine if the stepper motor can provide a sufficient voltage when it is used. Now that we've discussed the program, let us now proceed on the demonstration. Emulate the program. Okay. And press run. Press 1 if you want to reset the stepper motor, and press 2 to select the counterclockwise or clockwise rotations, and press 3 to select continuous rotation or manual keyboard input, or press 4 to turn the stepper motor on, and press right arrow key to the turn right, and press left key to the turn left, and press Q to quit. And first, let's choose the clockwise or counterclockwise rotation. I choose 2 and 3 turn continuously rotation, and press 4 to turn on the stepper motor. And now the stepper motor turns clockwise. If you change your mind, reset the stepper motor. Press 1 again, and the stepper motors come back to 0. Wait. And press 2 if you want to turning counterclockwise, and press 3 to stay put continuously, and press 4 to turn on the stepper motor. Again, 2 counterclockwise, and 3 continuously, 4 to turn, and now the stepper motor turns to counterclockwise rotation. And if you want to turn the manual keyboard input, but first press 1 to reset the stepper motor, and the stepper motors come back again into 0. Wait. Wait. And press number 3 to select manual keyboard input. Press twice the number 3 continuously, and manual keyboard turn manually, and press the left arrow key or the right arrow key. I press left arrow key, and it goes to clockwise rotation, and I press right arrow key to counterclockwise rotation. And now that we have proven that stepper motor rotates, we can conclude that it conducts sufficient voltage on our devices we will use the stepper motor. I hope we help you to this program created by our group. Thank you for listening.